Hello friends, I, BHATIA, welcome you to my YouTube channel Maths DNA from origin to infinity. In this video, we are going to discuss 6 examples of binary operations and check 3 properties: associativity, commutativity and identity. But before that, let me share something with you. We believe that to qualify 4 different examinations, all you need is just one single book, that is, all in one book with 2000 plus solved questions. For this, you can register at our WhatsApp number given below. Moving on to the lecture. As I said earlier, the lecture is of linear algebra, third lecture, and the topics are binary operations with 3 properties: associative, commutative, and identity in English. So let us begin. The first example, let us consider a set A with all the 2 cross 2 matrices having integer entries. What is the set A? Set A is set of all the 2 cross 2 matrices with integer entries. All the entries are integer. Then we take two elements from the set A, P and Q, where P is equals to Pij 2 cross 2 matrices and Q is equals to Qij 2 cross 2 matrices. Here both P and Q, Pij and Qij are integers, and we define the first operation star 1, that is P star 1 Q is equals to Pij into Qij, component wise multiplication. Be very careful over here. We have defined it as component wise multiplication. In matrix there are two types of multiplication: component wise multiplication and ordinary matrix multiplication. You already know what is ordinary matrix multiplication, but here we have defined it as component wise multiplication. Let me give you an example to make it more clear. If we take two matrices 1 minus 1 2 0 and 2 minus 1 minus 2 0, and we multiply it with component wise multiplication, then the result will be 1 into 2, first element with first element 2, minus 1 into minus 1, second element with second element 1, third with the third, 2 into minus 2, that is minus 4, and 0 into 0 will be 0. This is what we mean by component wise multiplication. So we have our set, we have our operation. Now we have to check four things: whether it is a binary operation or not, if yes, is it associative, is it commutative, and what is the identity element if it have it. Starting with the binary operation, clearly it will be a binary operation because if we multiply any two integers, the result will also be again an integer, and it will again give you a 2 cross 2 matrix. So Pij into Qij will also be an integer, and thus you will get the operation as a binary operation. So first one is correct. Moving on to the associative property. What do we mean by associativity? That if we multiply in order of PQR and PRQ, where P and Q are operated first or Q or R are operated first, the results will be same because our operation, that is normal multiplication or component wise multiplication, is associative. So with matrices also it will be associative. You can easily take example and say it. So it is associative. Moving on to the third one, commutative property. Now matrix multiplication, integers multiplication is commutative. 2 into 3 is equals to 3 into 2. Here P star 1 Q will be Pij dot Qij and Q star 1 P will be Qij dot Pij, where Pij and Qij are both the integer entries, and multiplication with integers is commutative. Remember, ordinary matrix multiplication is not commutative, but here we have not defined it as ordinary matrix multiplication. We have defined it as component wise matrix multiplication, so it will be commutative here. And the last one, identity element. We all know what is an identity element, that if P star 1 E is equals to P and E star 1 P is also equals to P, if we multiply that element with any element of the set, the remaining element is obtained and identity is sacrificed. So here it will be Pij dot Eij is equals to Pij Cancelling out Pij gives us Eij is equals to 1 for all I and j. It means that our matrix E will be 1 1 1 1. It is a 2 cross 2 matrix and 1 1 1 1 are the integer entries, so it will be in the set. It is possible in some examples you might get an identity element, but it is not inside the given set, and we will see that also ahead with the other examples. Moving on to the second question. The second question is again taking the same set A is equals to set of all 2 cross 2 matrices with integer entries, taking two elements from it P and Q, and now we have defined P star to Q, another binary operation or another operation as ordinary matrix multiplication. Here is the way you multiply the matrices, that one, ordinary matrix multiplication. So whenever you are attempting any question in an examination, read the question carefully. What have they defined? Is it component wise or is it ordinary matrix multiplication? The example of ordinary matrix multiplication, as you know it already or you are doing it from school level, 1 minus 1 2 0 multiplied to 2 minus 1 minus 2 0 gives us 4 minus 1 4 minus 2. You can easily multiply and see it. Now will this be a binary operation? See, the operation is ordinary matrix multiplication, but at the end of the day both the entries are integers, and over integers it is closed, as well as it will be added to another integer, and again we will get the integer entries only. Easily you can take any example or arbitrary P11, P12, P21, P22, and similarly Q11, Q22, Q11, Q12, Q21, and Q22. So it will be a binary operation. Associativity. We directly know that ordinary matrix multiplication is associative, so no need to check this. See, sometimes you need to check whether the given properties are true or not, but if you know, then don't waste your time in simplifying simple ones and go for the difficult ones. So remember the results very carefully. Moving on to the third one, commutative property. Clear, matrix multiplication, ordinary matrix multiplication is never commutative. You can also take example P star to Q and Q star to P. Clearly equation 1 and equation 2 are not equal, and hence the matrix multiplication of ordinary, that is not commutative. And the identity element, we know it, but still let us find it. P star to E is equals to P is equals to E star to P here, and that will give you 1001 as the identity element, and 1 and 0 are both the integers, so E, that is our identity element, will belong to the set A. Clear? I hope both the examples are clear to you. Now moving on to the third example. This is a good one. Set A is defined as set of all the integer entries, but now all the entries are equal. Aij is equals to A. See, a small change in the question can make a lot difference in the answer or a solution. So be very precise when you are reading the question or solving it, because if you do not understand the question, you will not be able to solve it. So read the question properly. If you find any doubt, feel free to ask us also when you are practicing. We are available for you. So this is a set of all 2 cross 2 matrices with equal integer entries. That is, all the 4 entries are equal. Let us move on to the solutions. P and Q are taken as again 2 elements, and P star 3 star 3Q is defined as component wise multiplication. Again, the operation that we are defined is component wise multiplication, but our main set is changed. Now we can say that a subset of our major set A, because in that A we had any integer entries, but here we need to keep all the integer entries as equal. Let me give you a small example by what do we mean by equal entries. Means all the entries are 2 or 3, and the component wise multiplication will give you 6 6 6 6. Again, 4 things we have to verify. First of all, whether it is a binary operation or not. Clearly, all the entries have become equal. They have not changed. So it will remain integer at the end. So it is correct. Also associativity, same. Component wise will be associative, or you can take three set P, Q and R arbitrary and multiply them and you will get it associative. Moving on to the third one, commutative. We already saw in the previous one component wise multiplication was commutative, and here also component wise will be commutative because P dot Q or Q dot P, where all the P's are equal and all the Q's are equal, will be equal. So equation 1 is equals to equation 2 and it is commutative. And the fourth one, identity element. Simply P star 3E is equals to P is equals to E star 3P should be there, and that is only possible when all the elements are again equals to 1, and all the elements in 1 means E is equals to 1 1 1 1, and that is again an element of our set A because all the entries are equal, so it belongs to the set A. Clear till here? Now there are three more questions which are as your homework. You have to do it yourself and comment down the answers, or you can share the answers to us on our WhatsApp number. Let me give you three examples, and still if you find any query, feel free to contact us. The fourth one, the set again is taken as set of all 2 cross 2 matrices with integer entries but equal integer entries, and we are defining now P star 4Q as ordinary matrix multiplication. What is it? Ordinary matrix multiplication. You have to check four things: whether it is a binary operation or not, associative property, commutative property, and identity element. If yes, mention the identity element and also check whether it is in the set or not in the given set. Moving on to the fifth one, set of all natural numbers. Take two elements A and B from the set A and define A star 5B as ordinary matrix multiplication. Sorry, it will be ordinary multiplication over here because as they are natural numbers. And then again check binary operation, associative property, commutative property, and identity element. And the last one, set of all even natural numbers, taking two elements and defining again as ordinary multiplication. Then whether it will be binary operation, associative, commutative, and identity, whether it will be in the set or not. It is possible that the operation might have identity element, but it will not be in the set. So three examples for your practice. Feel free to ask if you don't know the answers, or if you are unable to solve it. It is possible you might be able to solve some steps and some might be remaining. We are there for you and we will help you. Comment your answers below in the comment box. Thank you. And you can be a member of our social club and watch 700 plus videos on our YouTube channel and get a complete study material for any higher mathematics competitive exam from our WhatsApp group.